Hello and welcome everyone. This is Swapnil Chodankar on behalf of TCS iON. I welcome you all to this free masterclass where we will talk about introduction to neural networks. Now today we are diving into how machines are learning and solving problems in ways that are inspired by human brain. We will also discover how neural networks help computers recognize patterns, make decisions, and even predict what's going to happen next. We'll break down the basics, like how neurons work, how they learn from their mistakes, and how different types of neural networks are used in real world applications. Now, from recognizing images to understanding language, whether you're just starting with AI or looking to sharpen your skills, this session will give you simple, practical insights that will prepare you for the future of AI. I am thrilled to introduce our expert speaker for today. A warm welcome to Mr. Sabyasachi Mukhopadhyay. Let me give a quick intro to sir. Now, he holds a Chanakya PhD fellowship from IIT Kharagpur, AI for ICPS, iHub Foundation, and is an assistant professor at BIMS Calcutta. Now, he has also taught at the University of Calcutta and SCIT Pune and contributed to organizations like Nanoscope Technologies and Root Alpha Ventures, a Google developer expert in machine learning and Intel software innovator. He mentors startups and advises Solier Initiative Private Limited. His research on AI in medical diagnostics has gained global media attention. He has also received multiple awards and grants. He has also spoken at prestigious events, including TEDx talks and contributions to Anand Bazar Patrika. And it's an honor and pleasure to have you on our session today, sir. Okay, so let me
Thank you
quickly
very
talk
much.
to the.
Thank you very much for the invitation. Thanks a lot.
The pleasure is all ours, sir. Now, Sabyasachi sir, before we start our exciting masterclass, can you briefly explain what neural network is and why is it such an exciting topic in today's world? Over to you, sir.
Thank you very much. Thank you very much for giving me the opportunity to discuss about the influence of the neural network in present world. So, as many have answered properly, that it actually mimics the human brain. Okay, so it is now it's one of the premier interdisciplinary area where you can see you can apply this type of the knowledges right from the healthcare domain to finance to transportation, uh, in entertainment in many areas. Like for example, if we talk about the image and video recognition purpose, so first thing which comes into our mind is the facial recognition. Okay, so for example, in your mobile phone or a security system and social media platforms, you can use it easily for the identity verification purpose. In autonomous vehicle, all of you know, in the self-driving car, you can apply the neural network concepts for figuring out the pedestrian and other vehicles, so that any collision should not happen. Or even medical imaging, for diagnosis, right from the diagnosis of the cancer, diagnosing diabetic retinopathy. These are the in early stages. This type of the applications are hugely appreciated, and all of you also are quite aware that in NLP, natural language processing, we have seen the applications, for example, in chatbot or the virtual assistants. Like we can talk about the AI-powered assistant like Siri, Alexa. Okay, where we have seen, or for example, Google Assistant, where we have seen the applications of the neural network to process and respond to voice commands and making them smarter over the period of time. Or even in language translations, where we have seen that easily conversion of the one language to another language. Okay, so using the neural network, or even sentiment analysis. Okay, like for example, social media review or the understanding the feedbacks. We have seen the very much pivotal applications of the neural networks. Even in stock market prediction, if we talk about the predictive analytics, we can talk about the stock market prediction. We have seen that how the investors are using the neural network to understand the dynamics of the market data and predict the stock prices. Okay, or even retail and marketing also. We have seen to the applications of the neural network to understand the customer behavior and personalize the product recommendation, optimizing price strategies. And that's why you may hear that in a lot of universities nowadays are offering business analytics, even during in management studies. Earlier days management was all about the qualitative driven, but nowadays it is quantitative driven. So that's why there is so much praise for the business analytics types of the courses. Even certain universities are also given MBA program in data science and data analytics directly. So because of this reason, because we have seen the ubiquitous applications of the AI, ML, and neural networks, even in, for example, fraud detection purpose in cyber security nowadays, you have seen the governments are investing a lot of funds in cyber security, because you see there are a lot of fraudulent activities that are happening, because today's world is a digital world. Okay, so neural networks can detect these unusual transaction patterns, or for example, it can identify the fraudulent activity in real time, and it can prevent the significant losses. Okay, network security, same thing applicable. Okay, it can identify the potential cyber attacks. Okay, by analyzing the network traffic patterns. Okay, and it can flag the anomalies that could suggest the cybersecurity threats. And definitely in, for example, in manufacturing or the supply chain optimization purpose also, like demand forecasting. Like, for example, we can talk about the neural networks can analyze the past consumption patterns to predict the future demand, or it can optimize the inventory level, and also it can reduce the wastage. Okay, so these are the very interesting cases. Even in the last example, for this case, I can mention like personalized recommendation purpose. That, for example, in streaming services, nowadays all of you use the Spotify or the Netflix. Okay, so there you can see that as per your choice, earlier search which you have made, accordingly neural networks gives you the suggestion of the movies, shows, music. Even in YouTube, the same concept is applicable. Okay, in e-commerce, already all of you know that, for example, retail platform like Amazon, they also use the neural networks to recommend product depending on the past purchase history or the browsing habits. So these are, in overall, you can see it's an integral part of our life, and that's why there are so much demand of the neural network related applications, and new job roles are also coining up, and that's why you guys all are here to attend this particular masterclass. I'm thankful to all of you. Hope to have a great time with all of you in next 40-45 minutes.
Thank you so much,
I
sir,
hope
for giving. Yeah,
clarifies.
it was a really brief explanation. And, listening to you, sir, today, neural networks is everywhere around us, like how you said. In fact, Shankar Ramwat in the chat has also mentioned the same thing, that it's a sort of cool stuff. Self driven cars is what you spoke about, Tesla. Voice assistant, you spoke about Siri, Alexa, and even in medical diagnosis. He says the same thing. And he also says that it's making our life easier and more interesting every
Absolutely,
day.
absolutely.
So, Shankar, it's really good that you've put this in the chat. It's really nice. Thank you so much. Now, without further ado, let's dive deeper into the exciting world of neural networks. I'll hand over this session to our esteemed speaker to begin the free masterclass. Over to you, sir.
Thank you very much. So let me share the screen with all of you.
Okay, while
Okay.
screen is being shared,
So I think the
I
screen
would
is
request
visible
everyone.
to all of you, right?
Yes, sir, it is. It is.
Okay, excellent. So, in today's session, Sarah already has mentioned, that we will have the session on the neural network. So, what we'll do, we'll have a little bit of overview on the basic theory part, and as soon as possible, we shall move towards the some hands-on implementation. So, those who are accustomed with this, they can consider it as a good practice for them, and those who are don't accustomed with it, they can try out to implement with me. And at the end of my session, nothing to worry about it. All these resources you can get from my GitHub. So I will share my GitHub account link. Also, I write Medium articles to guide the students or the practitioners, those who are planning to switch their jobs. So they can also maybe become useful by using it. Some of my small bites of the talk you can get from my YouTube channel also. So I will share all the resources. So nothing to worry about it. So meanwhile, I will give you the demonstration from my demo window. I'm just writing here Google Colab for those who are new to it. So they can simply type Google Colab, okay, and they can open it. Okay, so just type Google Colab, okay, and click on the Welcome to Colab button. Click on the Welcome to Colab. Okay, these are the very simple steps. Those who are new to it, they can do it. Okay, and then once you open it, you see the plus new notebook button is there. Okay, so please click on it. Okay, so it will be easily openable. Okay, now once you are opening it, so let me go back to my original notebook. So once you open it, you see, let me show it from here also. Plus code and plus text button. These two buttons are available. So from the plus text button, you can add up text if required, and plus code button, you will write the code. And this is the run cell button. So once you are done with it, you can click on it and it will execute, and also green tick will appear if it can execute it successfully, and some runtime will also be shown to it. So before going to this, now let me start with right from the beginning. So you can see some of the text, important text I have added for you so that you can easily follow what I am saying. Okay. So like all of you understand, I mentioned correctly, okay, like the neural network or artificial neural network. So those who already know about this, fine. Those who are new to it, they might figure out something difficulty whether this ANN and NN both are same or not. NN stands for neural network. Artificial neural network means NN. Okay. Now these are used interchangeably. Okay, and artificial neural network is being used to just to separate neural network concept from the biological neurons. That's why people sometimes also call it as the artificial neural network. Okay, so artificial neural network, like I mentioned during the beginning of my talk, okay, when I was explaining about the relevance to the real world application purpose. So, like I mentioned, that it's an attempt to recognize the complex pattern involved in the data, okay, by mimicking the human brain activity. Okay, exactly the way human brain operates, it actually tries to follow that. Okay, so the basic component, if we break down the overall things, the first thing which will come up, that will be the neuron. Okay, so what is neuron? So it will basically a unit which receives the input, apply some weights, and pass it through an activation function. So we will talk about the activation function also. It's a very important concept. Okay, so before going to that, I want to highlight few of the layers. Okay, so there are few layers. Like for example, we can talk about the input layers. As the name suggests, it takes the input. Okay, hidden layers where the actual computation will take place, and as the name suggests, output layer will give you the final prediction. Okay, now the weights. There are one concept like weights. So what does it mean by weight? So the values will be there, so it will adjust during the training, and its main purpose will be to minimize the error between the predicted output and the actual output. So it will minimize the error. Okay. And there will be the concept like activation functions also. So what does it do? It actually introduces non-linearity to the model. So activation function purpose, you will hear about the sigmoid, tan, hyperbolic. They are mainly used in machine learning. And in deep learning is nothing but an advanced machine learning, you can say. So whenever you are dealing with a data in order of 10 to the power 5 or nearby that, so you can apply deep learning there. So there you will see activation functions like rel. Okay, quite often used. And another important concept that is related to gradient descent. Okay, so optimization techniques is used to minimize the loss function by adjusting the weights. This is the basic concept. Now, just to give you an overview, so for those who are going through the neural network, so what we have discussed so far, so this has been shown with the help of this. Okay, there will be the input layers, hidden layers, and output layers. Okay, so the main computation will take place in the this particular hidden layers. Okay, now the next interesting area which we will see, that is the hands-on implementation. So this is the background setup for you, where we have seen the basic formation of the neural network. Okay, so the first part of the important contribution here, which for implementation purpose, what we'll do, we'll do the pip installation of the TensorFlow. Okay, with the pip install command. Okay, so here you can use the PyTorch also, but in this case, in this example, we are going through with the TensorFlow. Okay, so let me tell you that we are using here Pythonic platform basically. Okay, so this TensorFlow or the PyTorch, whatever we mention, or Keras, these are the Pythonic framework. Okay, so Pythonic framework actually helps you to implement this type of the problem solving cases quite easily. Okay, so in generally data science, data analytics, or AI domain, people use two programming languages quite frequently. Even for example, R programming is also there. People sometimes use R programming, but in generally, people from the economics background or statistics background, they prefer R. It's a general trend I am talking about. They may use Python also, because Python you will get a lot of support. This type of the framework supports are available. Mainly statistical computation purpose, people goes with the R programming. That those things you can do in Python also. But in AI or AI related stuff, it will be better that if you follow Python more, if you give preference Python more, and Python is an open source case. Okay, so first thing which we'll do, that will be the pip install TensorFlow. So what I will do, I will copy this and I will show you the demonstration in the demo window. So this is, I am giving the name as demo 1. Okay. So those who are doing it by hand, so these are very simple command, you can type it easily. Okay, so I am clicking on the run cell button and executing it. Okay, so it's now 5:20. Okay, so complete this step by 5:21. I think 1 minute will be good enough for you to implement this particular step. This is a very simple step. So please complete this, and once it is done, okay, we shall move ahead. Okay, so 1 minute will be good enough. So it's now 5:21. I shall wait till 5:22. Okay, you see, like I mentioned, that after the successful execution, this green tick will appear and some time will be shown there, like 8 seconds, 5 seconds, in some cases 0 second. Okay, as per the execution time, the executional time will be shown here. Okay, so I am waiting for all of you. Please do it. Okay, try to do it by hand. It will give a lot of pleasure. Those who are new to it, it will give you a lot of confidence to you. Okay, so it will give you the confidence like you also can do this type of stuff. Okay, and please do it. Okay, and those who already know it, please consider this as a good practice. Okay, there is no harm of practicing more, right? So do it. So I shall wait for a few more seconds and then move to the next step. Please finish it soon.
Sure, sir. We've got Shraddha who says that they've already tried it, they've done it.
Excellent,
Akshita
excellent.
says that they've done it. Gargi
Absolutely.
Roy says that they've done it. Trupti says that she's done it. So really good.
Oh, great, great,
Uh,
great to see that
yeah.
all of you are actively participating. So let us move to the
Yes.
next part. Okay, so now in the next step, once you complete it, so next step will be the loading of the dataset. Okay, so in dataset description, here we are using a standard dataset that is called the MNIST dataset. The full form is Modified National Institute of Standard and Technology. So it is basically a collection of the 70,000 grayscale images. Okay, so here will be the handwritten digits from the 0 to 9. Okay, each basically 28 by 28 pixel. And by the general provision, what we are doing, this type of the data set people use to training, take the training for the computer vision related tasks. So 60,000 for the basically for the training purpose and 10,000 for the purpose it is used. Okay, so now first of all we shall implement the basic steps related to the data set. So always remember that the loading of the data set, pre-processing, those are the very, very important steps, because you may use many optimized classifier for the classification purpose, but it will only give you the proper result when you are doing the pre-processing in a proper manner. So for this purpose, we are importing TensorFlow as TF and then TensorFlow.keras. We are using the inbuilt dataset present in the package. Okay, so you are not taking some downloading some dataset from the websites or something like that. Here we are using the intrinsic dataset. Okay, that is also doable. In some other examples, if I get opportunity, we shall discuss them. Okay, so loading of the MNIST dataset, what we are doing, MNIST.load data, and we are storing the result, okay, under the xtrain, ytrain, and the xtest, ytest. Okay, and then what we are doing, we are normalizing the data to the values between 0 to 1. So normalization is one of the very much important case, because you see different data set may have the different scale, present may present different scale. Something maybe in 0 to 300, something maybe 0 to 700. So make them between 0 to 1 to compare their performances. It will be always preferable that if we can do the normalization. So here what we are doing, xtrain by 255. Okay, as this is a grayscale, so that it will vary from the 0 to 255, because there will be a range from the 256 cases 2 to the power 8, so it will be 256 cases. Okay, so 0 to 255 is the overall range, so that's why we are dividing 255 in the denominator section. Okay, so xtrain by 255, we are normalizing it, xtrain data, as well as same thing for the xtest data as well. And then what we will do, we will try to flatten the image to 1D vector. Okay, now flattening, it is the operation. So what will happen in that case, it is as it is a 28 by 28, so it will give you the 784. Okay, so what it will happen, that there are 60,000 image for the training purpose, so 60,000 row will be formed and 784 columns will be there. So -1 in left hand side under this xtrain dot reshape, if we see in the index value, -1, it is in the left hand side. So it is adjusting the number of the rows with the total, so that what will happen, that total elements will remain same. Okay, so if 28 by 28 is there, so 28 into 28, 784 columns will be formed. Okay, so in this way the flattening will happen. Okay, and for example, there are 60,000 images. So for per image, there will be 784 columns. So there will be for per row, there will be 784 columns. So for 60,000 images, there will be 60,000 rows. Okay, and X test in a similar way, you are also reshaping it. So X test dot reshape -1 28 by 28. Okay, so this is how you are happening the flattening operation. Okay, so flattening operation, you can basically say that, for example, if we have an image in it is basically remains in matrix format. So in the first we have ABC, in second we have DEF, in this type of things. So what will happen in that case? You can unfold them horizontally. You can horizontally write them as ABC and DEF in this way. Okay, so you can unfold horizontally or you can unfold vertically. So this is called the unfolding of the image. Okay, so this is basically a flattening step, flattening operation, which is very much important operation. So what I am doing, I am just putting this particular portion of the code in the demo window so that you can easily implement this particular portion. Okay, so just a second. So you see, once we are doing it, so there will be two options are appearing: plus code and plus text button. Click on the plus code because you are planning to add the code. Okay, and you are running this particular portion. Okay, so it has executed successfully. Okay, so please, those who are doing it, please do it carefully. I think it will be better that if I can put it in the comment box, it will be easier for you. Just a second. Let me put it in the comment box so that you can do it easily. Otherwise, if you keep on typing, it will take a lot of time. I am putting it in the comment box and giving you 2 minutes to implement it. I think that would be better. Just a second.
Thank you so much, sir, for helping the audience.
It will be easier for them actually.
Absolutely,
Otherwise,
absolutely.
it will take a lot of time because those who are already expert, there is no problem. But those who are new, for them
Right.
it will take.
Correct.
So I am removing the comment section because there will be in comment box also there will be some limitations of the word. So I am removing the comment. Just a second.
Right. So Priya, I see that you've put in a chat saying, please explain this one more time. I would request you to please stay tuned. I have got just the answer for you. In a while, I'll let you know what can you do. But for now, everyone, please stay attentive as Sir is also giving you all information in the chat. So it'll be easier for you all to try that.
So in the comment box, please, all of you, please take care in the comment box. I am posting the code in the comment box.
Sure, sir.
So in the step, I repeat what we have done. So basically, just a second. I am taking session. I am taking session in the boardroom. Okay, please contact me after 6. So let me just tell you, first of all, importing TensorFlow as TF, what we have done here. So we have imported the TensorFlow. And then what we have done that from TensorFlow.keras dataset, we have imported MNIST. I am repeating the steps. Okay, so those who are implementing now, just listen it carefully. Then we are loading the MNIST data. Okay, so that's purpose, MNIST.load underscore data, we are loading the data. And then we have normalized it. So x10 divided by 255, x10 divided by 250. So in the normalization, what will happen? All the value will lie between 0 and 1. Okay. So this is how the normalization is happening. And finally, what we have done, we have converted the 2D image to 1D data. Okay. So that is one of the trick is called the flattening operation. So in the flattening operation, what we have done, so we have basically a reshape. We have used the extend.reshape and extest.reshape. So the image size is 28 by 28. So if you are doing the flattening, so 28 into 28, 784 column will be formed against each row. There are 60,000 images, so there will be 60,000 rows, and against there will be 784 columns. Okay, that is what we have done. So just a second, let me reshare the screen. So it's now 4:31. Okay, sorry, 531. So I hope by 5:32 all of you can do it, because now you are just extracting from the comment box. Okay, so please complete this step. Then we shall move to the step 3. That would be the discussions related to building the neural network. That means next step what we'll do, we'll use the simple feed forward neural network case. Okay, and during the implementation, we will also discuss some of the important theoretical aspects which is required for the foundation of your knowledge.
So thank you so much, Sabyasachi sir. It really, I appreciate this. So for people who have already knowledge about this, they are getting a refresher, a training. But for those who are new to neural networks, they are getting a hands-on, as if you're holding their hands and taking them through. So that's really nice.
Thank you very much for your kind appreciation. So we shall wait for a few more seconds and then move to the next part. That will be the step 3, building neural network. Okay,
Sure, sir.
so in the next step, we shall use the simple feed forward neural network.
In fact, we've already started getting comments. Trupti says she's done it. Ashwin says he's done it. Bhavin, Mehta, Harshil, Shraddha, they've all done it, sir. So you can proceed with the next part.
Okay, thanks for your kind acknowledgement. So let us move ahead. So now in the next step, we will implement a few of the very important cases. So before going to that, the concepts which we are going to use in the next steps, I'm discussing here. So one of the case which we will consider, that will be the optimizer case. So we have seen that gradient descent is used as an optimization purpose. So Adam optimizer, which is the short form of the adaptive moment estimation. This is one of the advanced gradient descent method. So what does it do? Actually, it computes the adaptive learning rates for each parameters by combining the momentums, or for example, the past gradients. And then what you do, you are scaling it by the squared gradient. So it basically, just for those who are new to it, they just consider it that it is very much well suited for the larger data sets and noisy problems. So here noise means the unwanted signals which are interfered with the original signals, or for example, it can be some saltpeter effect on the image. That is also one of the noise. Okay, so basically which we call as the granular noise, sometimes with the median filtering to remove those noise. So there are many pattern of the noises. We are not going into it. Just remember that in case of the noisy cases or the large data sets, so it is being used for to speed up the overall convergence performance. So adaptive moment estimation, or the Adam optimizer we shall use here. There will be also the use of the sparse categorical cross entropy. So what does it mean by the sparse categorical cross entropy? So it's basically a loss function which will be used for the multi-class classification problems, where labels are provided as integers instead of the one-hot encoded vectors. So what it does, it actually calculates the difference between the predicted probability distribution and the true class levels, and penalizes the inaccurate predictions. So it is very much efficient for the large level data set also. And there will be a few examples of the activation functions. Already we spoke about the activation function. So there you will see in the next step, there are two types of the activation function which you'll use. So first one will be the softmax activation function. So it actually converts the vector of rows. So raw score, actually vector of raw score, which we call as the logit. So it converts the logit to the probabilities. Okay, so basically it will normalize the output range between 0 to 1. So you, all of you know that if you add a sum up all those probability cases, it will be 1 at the end. So for example, to your understanding purpose, I have given some raw values from the neural network. So the raw output values from the neural network, which we call as the logit. So these logit values, if we see, there are values like, for example, 2.0, that means 2, 1, and 0.1. There are three values. Okay. Now, the first steps, what we will do to calculate the softmax activation cases. So we shall do the exponential of the each logit. So you can see, so it's square. Okay, so we are doing the exponential of the each logit case. So each square, it is 7.389 approximately. In second case, what is the value? 1. For example, to the power 1, the value will be 2.718. Okay, approximately. Or for example, in third case, the value is logit value is 0.1. So what will be the value? It is e to the power 0.1. Okay, so overall it is 1.105. Okay, done. It's a very fast step. And then you have to normalize. To normalize it, all of you know that denominator, it will go after taking the summation. Okay, so 7.389, 2.718 plus 1.105. So overall summation, it is landing up with 11.212. Okay, now let us calculate the probabilities one by one. So P1 equals to 7.389 divided by 11.212. So the value will be 0.659. First probability case will be 0.65. Second probability case P2, what will be the case? 2.718. Okay, divided by the 11.212. So the value is 0.242. Okay, so just a second. Sir, I am taking the session, masterclass session in the board. I will call you after 6. Okay, so now P3, what will be the P3? In the P3 will be 1.105 whole divided by 11.212. So the value will be 0.098. Okay, so P1, P2, P3. Okay, so these are the cases. Now, these are the softmax probabilities. Okay, so as you can see, 0.659 is the highest probability. Second highest probability is your 0.242 will be the second highest probability. And the third highest probability will be your 0.098. Okay, so from the highest, first class having the highest probability, second class having second one having the second highest probability, and third one is the last, but lowest probability. Sorry. So if we make the summation of these three cases, so what will be the overall cases? So the overall summation will be 1. Okay. So this is how you can do the probability calculations P1, P2, and P3. So I repeat the steps of this softmax activation function. So in some cases, you may figure out in some job interviews or even in the entrance test of the different AI department or data science department, this type of the interesting questions people sometimes give. Apart from the coding, you have to understand the math behind it. It's a very simple mathematics. Always remember log it. Log it is also a very important but simple interview question. Okay, what is log it? So remember, it's a raw output. Okay, so it is a raw output from a neural network. So once you get the log it value, so what we have to do? We have to apply the exponentiation over it. So its square value is 7.389 e to the power 1. It will be 2.718 e to the power 0.1, 1.01. Fine. Now I have to normalize it. So for normalization purpose, we have to make the summation. So if you do the summation of these three output, it will be 11.212. Okay, and then what we have to do? We have to divide. So this will go under the denominator section, and numerator section will be the individual case, exponential case of the log it. So in this way, we will calculate the probability. So first probability, this is the highest one, it is 0.659. Second probability, what we are getting, that is the 0.242 P2. And the third probability case, it will be the 0.098. Okay, so in this way, you will get these three cases. So these are the softmax probability. Okay, so in overall summation of these three cases will be the 1. Okay, so this is how we calculate the output. Okay, and this is how from log it to probability conversion we do using the softmax function. Okay, so in the softmax, this is the one of the case. Okay, for the softmax case output, the curve looks like this, activation curve. Okay, so you see in the y-axis output, the probability value always lie between 0 to 1. So this will be the probability value. Okay, and this is how you do this type of the implementation. Okay, using this type of the applying simple mathematical cases. Now the ReLU activation function, and another one that which we'll discuss, that is the rectified linear unit. Okay, so in rectified linear unit activation function, what does we do? We basically returns the input directly if it is positive, otherwise it will be 0. Okay, so it introduces basically non-linearity to the model and making it widely used in neural networks. So it helps to avoid the vanishing gradient cases. Okay, so for example, if we have the input like -2 +3 -1 5. So like we mentioned that if it is a non-zero cases, it will return the value y equals to x. Okay, so it will give you, for example, what are the non-zero cases? Second case 3, so it will be, the output will be 3 for the input 3. And the fourth one, if it is 5, the output will be 5. Okay, but for all the negative cases, output will be 0. So that is how it is avoiding the vanishing gradient problem. So these are the very important interview question, that what is ReLU or the rectified linear unit, and how does it help to avoid the vanishing gradient problem, which is not doable with the help of the your sigmoid or the tan hyperbolic, which you use in during the machine learning. Okay, so this is how it helps. Okay, and the explanation I also added for you. Okay, so you can easily get the answer. Okay, so now the tan hyperbolic, the ReLU or the rectified linear unit, what I discussed exactly in the figure in the screen, you can see. Okay, so if it is greater than 0, then it will be y equals to x. 0, or for the negative value cases, y will be 0. So this is the beautifully explained, I think, pictorial representations where you can get the entire idea of the activation function. Okay, so from the one of the two most important activation functions which are used during the implementation of the deep learning, you will use frequently. One is the ReLU, and another one will be the softmax, so which we have discussed. Okay, now I believe that let us move to the implementation purpose. So during the implementation purpose here, what we will do, so model equals to tf.keras.sequential. So we will keep on adding a one by one dense layers. So 128 will be the neurons. It is at first it is creating the 120 neurons where we are using the activation function ReLU. The input shape already all of you know what is the shape we have taken during the flattening operation. Okay, 28 by 28. So 784 will be the input, which will go into the input shape. And the next tf.keras.layers.dense, what we are doing, because output class, always remember they are a handwritten digits, I told you. So the value is ranging from the 0 to 9. Okay, so because of that reason, there will be 10 output classes. There will be the 10 output classes from 0 to 9. So because of that reason, in the first argument section, it will be 10. And the second one will be the activation will be the softmax. Okay. And then finally, model.compile. So optimizer, here we are using the Adam optimizer. That's why we discussed about the Adam. Then loss, parts categorical cross entropy concept already we have discussed, and metric will be the accuracy. Okay. Measuring metric. So all these concepts we have used, discussed earlier, which are unknown to you. And this is the chunk of the code which we are going to discuss now. Okay. So let me put it in the comment box section for your easier implementation purpose. Okay. Just wait and watch. So in these steps, we are building the neural network model. Okay.
So while you're pasting that in the chat section, Sabyasachi sir, we've got a question from Gargi Roy. What is the importance of this normalization between 0 to 1? That's the question.
Okay. So like I mentioned, that normalization makes it scale invariant. Okay. So it helps you to deal with the different categories of the data in different scale. Okay, one data may be scale between 0 to 700, another one may be scale between 0 to 1200. So once you try to compare their performances, so it will always better to make them in some scale independent factor. Like for example, if we do the normalization, it will be between 0 to 1. It is the image case. That's why we are dividing it with the help of the 255, because it is the grayscale cases. If we, for example, if we are using some other cases, okay, so what we can do, data minus mean of data divided by standard deviation, that is the standard formula for the normalization cases. Okay, so why do we do the data normalization? This is also one of the very important interview questions. Okay, so always keep it in your mind. Okay.
So I hope that answers your question, Gargi Roy.
Remember
In
the
case if you
formula.
all have...
This is the image case. If it is a grayscale, we divide it by 255. Okay. But if it is in generally in other type of the data minus mean of the data divided by standard deviation. That is the standard formula.
Thank you so much, sir. Gargi Roy has responded, acknowledged, and said thank you, sir.
Okay, so this particular portion, it's now I think 5:45. So I am waiting for a few more seconds, and then we shall move to the next part. So there we will discuss about the training of the model. So those who are finishing it, keep on acknowledging. It will help me to also share to understand that how you are doing. Okay, whether you are able to follow us or not. So it will give us a lot of encouragement also once we see during this type of the hands-on session in remote mode. Once you give us some acknowledgement that you are doing, it also encourages us to plan more sessions like this.
Absolutely, sir. The way that you're explaining it to the audience, it's really good. After every section, the way that you're summarizing, you've got pictures, you've got notes. So I'm sure that it's going to be very helpful to everyone. So while you're preparing for the next section, Sabyasachi sir, let me quickly take them through to the certification course that we've come
Sure,
up
please
with.
go ahead. Please go ahead for the certification.
Right. So for everyone who had questions, during the session, during what Sabyasachi sir was teaching us, and even Priya, you had a question. So for all of y'all, we've come up with this. we are thrilled to announce the launch of Cohort 3 for our online certificate program. If my colleague Sonali, if you can bring the slide up, it will really help everyone understand it. So this is developed with IIT Kharagpur in collaboration with TCS iON. And after the successful completion of cohort 2, we are now ready to welcome new learners to exclusive course focused on hands-on AI for real-world applications. Now, this program is designed to equip you with essential AI skills through a blend of practical experience and theoretical knowledge. Now, the course emphasizes on 80% hands-on learning with real-world applications and 20% theoretical insights through live sessions with IIT, KGP faculty and industry experts. You just heard Mr. Sabyasachi sir explaining this was hands-on. It was like a real classroom, live classroom that he's taking us through. And this course is built around practical exercises, live projects, industry case studies. This will give you all an overview, giving you all also an opportunity to apply your knowledge in the real world scenarios. Now, whom is this course for? You all may have this question. It's ideal for students, it's ideal for freshers and working professionals who want to gain practical AI and machine learning skills. Upon completion of this course, you will also receive a certificate. You all see that on the slide there. You all will also receive a certificate. Now, this certificate will be from IIT Kharagpur and TCS iON, along with career support to help you advance professionally. Now, there is a surprise element to this. The top 10% whoever clear the certification course will be awarded at the IIT Kharagpur campus. So you all will receive a personal invitation, and you all can go there, and they will give you the certificate in person. So there is 100 hours of overall experiential learning. You'll see that there. There's flexibility in learning. There are weekend sessions for those who are working, the working population. And apart from this, once when you complete the course, you all may have a question: what are the job roles that I would have? So the job roles, it's mentioned there, the potential job roles, y'all can be a machine learning engineer, deep learning engineer, ML architect. So there are a lot of opportunities once when you complete this. Now, you all may have a question. Okay, I have heard Sabyasachi sir with the first part of the masterclass. I've heard you, but how should I go ahead and register for this course? I am interested. How should I register? So we've got, if you all have any questions, you all probably may not have questions right now, but maybe some questions pop up later in your mind. You all can always reach out to us at info.tcsionhub@tcs.com. You'll see the QR code there. Just scan the QR code with your phones, and it will take you all to the IIT KGP, the website. You'll also see the URL that's mentioned down there. If you're not able to scan this, just type the URL and it will take you there. And there are very limited spots available, so quickly register before. Now, as y'all, I told y'all at the initial part that there will be a quiz. Whatever Sabyasachi sir is teaching us, there'll be a quiz at the end. We will want to know if y'all have understood whatever he has taught, and basis the quiz answers that y'all give, we will give you all a certificate. So please stay tuned, everyone. Please stay tuned. Do not go away. Let me hand over the stage back to Sabyasachi sir. Sir, please take us through the second session. Thank you.
Sure. So I just want to, sir, you beautifully explain the utility of the course and usefulness of the course. I just want to highlight a few points as it is aligned with this. So this is one of the sessions which you are doing in neural network. So in if you join the high program, or if you're any senior or junior who already have done the high program, you can ask them that we start from the basics of the linear algebra. So there we will cover the basic concepts related to eigenvalue, eigenvectors, which is very much important for doing the principal component analysis, singular value decomposition kind of operations. And after that, once we complete these particular steps, we move towards the gradually nitty-gritty of the machine learning concepts. So there will be supervised machine learning, unsupervised machine learning, along with their corresponding hands-on sessions. And before going to that, those who don't know Python, for them, basic Python programming course will be there. sorry, Python program session will be there. And then what will happen gradually after covering machine learning, we shall move to the deep learning, advanced deep learning. Okay, so in deep learning, advanced deep learning part, you will see that like from the basic artificial neural network, we will cover up to RNN and CNN type of the concepts. Then we shall move towards the concept that to transformer, okay, GPT. There you will, all those sessions will have the hands-on part as well. So IIT Kharagpur professors will teach you, the PhD research scholars like me will take the hands-on sessions, and in there will be the industry experts also. Already Sarah has mentioned that. So those type of the guidances you will get. So the type of the guidance you are getting during this masterclass free hands-on session, you will get this type of the guidances during the entire session. So right from the all the particles, important particles in the AI course, that will be covered in high cohort 3. Okay, so without doing any further delay, let me move to the next part. Let me share the screen. I think the screen is visible to all of you. So now in the next step, we will shall do the training of the model. So training the neural network on humanized data set. So here we are using the epoch 5. So epoch means the number of the times your algorithm seeing the entire data. Okay. So here we are doing epoch 5. So you will see epoch 1, epoch 2 out of 5. How many times whenever we are moving forward. Okay. So you will see the improvement of the accuracy. It started with the 87.50. 0.8750 means 87.50%. Then, for example, 96.43, then 97.71. In this way, we are moving towards the 98.65. So, gradual improvement of the accuracy. Okay. So, let us implement this. This is a very simple single line of the code. Okay. Let me post it in the comment box section so that all of you can do it easily. Okay, so please implement this particular model fit portion. So you will see as the epoch progresses 1, 2, 3, 4, 5, we'll see there is a improvement of the accuracy.
Okay, so we've got Bhavin who said it's working, sir. Ashwin says done, sir. So everybody's attentive, Sabyasachi sir.
Great to see right from the beginning to end you are doing it so seriously. Thank you very much. It gives us a lot of encouragement to come up such type of the sessions. So those who already have finished it, so let us move ahead for them. And those who are already doing it, please do it. I believe that you will complete meanwhile. So step 5, the next step will be the evaluate the model. Okay, so now evaluate the model on the test set. So what we will do, we will apply the model dot evaluate function over x test and y test. And if we see the output in terms of the whenever we are printing it, like the way you are printing it, we will get the output. So print test accuracy. Okay, so it will consider the floating point for f, and then after colon we see we are putting the value under the curly braces test underscore ac. Okay, so under that actually we are storing this particular variable, we are storing the accuracy. So you will see this accuracy is appearing as the 97.67. Okay, so approximately if we take this 97.67% is the overall test accuracy which we are getting from it. Okay, so so let me share this particular chunk of the code in your a comment box section so that you can implement this part easily. Okay. Okay. So please finish this portion. So once you finish this portion, you will get the accuracy of the 97.67%. Or it may vary a little bit also because each time whenever you are doing the randomization, it actually there will be some variance in the output, but it will be a very good output. whenever you are getting something more than 97%, that will be very good, very satisfactory result. Okay, so oh great, you also got 97. Okay, 97.79%. Excellent, excellent. Around 98%. Congratulations to all of you. Great to see that all of you are doing excellent. Okay. Thank you very much. Thank you very much for your attentiveness during the entire session. I'm thankful to all of you. I am thankful to TCS and for giving me the opportunity to interact with these wonderful audiences.
That's wonderful, Sabyasachi sir. You know, once again, it's really our pleasure that you've come on this platform and the way that you've been taking this session, the masterclass. It's really indeed a true masterclass. So, should we proceed with the quiz questions now, sir?
Please go ahead with the quiz question. I
Okay.
am done.
So, to all the audience, I hope you all are ready. The quiz questions are going to start now. We'll give you all maybe a minute or 60 seconds to answer this. Once again, the person who answers the best, your scores will be evaluated. Your responses, how quick you all are for the quiz, and the top performers will receive an active involvement. So you all see this on your computer screen now. The first question that's there: what is the primary role of activation function in a neural network? So you'll see the options there to scale the input data, to introduce non-linearity into the model, to reduce the training time, to update the weights of the network. Come on, if you all can respond, you all can do that right now. The Slido poll has also been launched. I see 8 votes now, 10 votes. Come on, most of you all, if you all can do that, it would really be great. Yash, I would appreciate if you could, use the Slido. Kamal, thank you so much. Tripti, try using the Slido app. If you're not able to do it, let me know. I'll help you all with it. Thank you, Aman. Thank you, Joshita. All right. So most of them are saying B. Some of them are saying A. Okay. So maximum responses that we have, Sabyasachi sir, it's towards option B, to introduce non-linearity to the model. That's 58%
I told that
approximately.
multiple times during the session.
Right. So they were attentive. That's wonderful. Okay, so let's quickly go on to the next question. Which of the following is a common optimization algorithm used in the training neural networks? Linear regression, gradient descent, principal component analysis, PCA, K-means clustering. Come on, if you all can respond to this one. Wonderful. I see people responding, 19 votes. We've got more than 50, more than 70 participants. Come on, if you all can select the Slido option. Most of them are selecting B, option D, some of them are selecting. Okay. So Sabyasachi sir, the winner in this one is option B, 88%.
Excellent, excellent. Great to see they are attentive to the session.
That's really wonderful. I'll move on to the last quiz question for the day. This will decide the certificates for you all. Okay. So in a neural network, what does the back propagation algorithm primarily aim to optimize? The initial weights, the activation functions, the output predictions, the weights by minimizing the error. Okay, let's see if you all get this correct. All right, that's wonderful. I see people responding. Come on, come on. We want maximum participation. 27 votes, 30 votes, more. Come on. That's wonderful. Okay. So many of them, sir, are saying option D. In fact, this is a clear winner. 91% say option D. All right. That's wonderful. So the way that you all taught them, sir, I'm sure that it has been registered. And if you all have liked the way Sabyasachi sir has taught you all can put that in the chat section. The way that you all liked this masterclass, what did you all like about it? You all can put it in the comment section now. If you all have any questions, we are here to answer your question. Now, please note that there is no question, that is foolish. Every question that you'll have, any doubt that you'll have, Sabyasachi sir is here to answer it. If not, you all can also always write to us. You all have our email ID, write to us, and we would be more than happy to answer all your doubts, all your questions. Uh, and the link to the certification that I spoke about. So this was just a part of it. This is just a masterclass, but the entire certification will give you all so much knowledge that you all will be ready for the real world. That's what the certification says, real world application, right? So you all can probably check that. So Shreya Roy says, sir, explain things too nicely. Thank you so
Thank you,
much.
sir, madam. Thanks a lot. Thanks for your kind
Jatin
effort.
also says, "Thank you, sir. It was really great."
Thank you, Jatin.
So yeah, that's the course. We've got a question. Yes, we want to know what deep for CNN and all networks. This is what Raj says, right?
Those who are saying thank you, thank you very much to them, Raj. For this, you have to do this type of the courses. You have to enroll yourself in I Cohort 3. You will definitely be able to learn CNN, RN, all those things in much more detail.
Absolutely. So cohort 1 and cohort 2 has been a success. Let me tell you all. And cohort 3 is now here for all. In fact, Akshita says studied for the first time and easily understood. Thank you so
Great
much.
to know. Great to know. Excellent. Excellent.
So that's wonderful. So with this, we've come to the end of the session. In case if you all have any more doubts, any more questions, you all can always reach out to us. I want to specially thank Sabyasachi sir. It's been a pleasure to be here in your masterclass, sir. The way that you explained, the way that you summarized everything that you taught them today, the diagrams to make it more easier for them to understand, your real world examples. It was really an engaging session, sir. Thank you so much. And
Thank you very much for your kind appreciation. You are also a wonderful host, I must say, Sapnil ji. Thank you
thank
very
you.
much for hosting the program so wonderfully. And most importantly, I also want to thank the audiences for their active participation. Okay.
Absolutely. So it's
Thank you.
nothing without you all, audience. Thank you once again for your time. See you all for the next masterclass. Till then, have a pleasant evening. Bye bye.